Imagine the sound of a whirring 2009 era CPU fan.
Oh, those things were incredibly loud.
Right. A really distinct, almost grating mechanical noise.
Yeah, you couldn't ignore it.
Exactly. So picture it slowly building in volume in a quiet room. The tension is mounting for a few agonizing seconds, and then suddenly it stops.
Just dead silence.
A stark, heavy silence. And I want you, the listener, to keep that sudden silence in your mind today, because that silence is the sound of $1 trillion global financial revolution almost dying in its crib.
It really was that close.
Welcome to this deep dive. Today our mission is to forensically deconstruct the source material from Satoshi Nakamoto, The Biography of a Ghost by Erasmus Cromwell Smith II.
Which is a fantastic, strictly documentary-style text.
Yeah, it's built entirely on digital forensic evidence, right? We're
Yeah.
talking SHA-1 digests, UTC timestamps, archived emails.
Hard data, no speculation.
Exactly. And today we are zeroing in on the second half of Chapter 3. We're looking at the incredibly fragile, just near disastrous first 72 hours of the live Bitcoin network following the Genesis block.
A crucial window.
Right. And to me, diving into this specific week, it's like listening to the first heartbeat of a new kind of organism. It's the exact moment a sovereign protocol was born out of raw code.
Well, looking at that exact same period, I see something entirely different.
Really?
Yeah, I see a display of near-catastrophic amateurism.
Amateurism. Wow.
Absolutely. When you strip away all the mythology and actually look at the forensic evidence compiled in this book, it is an absolute miracle this thing survived its own launch.
Okay, let's unpack this.
We are looking at a system that was supposedly designed to replace global finance, right? Yet it was hanging by a remarkably thin, highly unstable thread.
Okay, but we need to start with the launch itself to really understand that fragility. We're moving from this sort of philosophical overview of the book right into the unceremonious moment the code actually hits the public internet.
The January 8th release.
Right, it's January 8, 2009. Satoshi Nakamoto sends a plain text email to the cryptography mailing list.
No PR firm.
No PR firm, no launch party, nothing. He just drops a download link for a file called Bitcoin 0.1.zip.
Just out of nowhere.
Yeah, and he essentially says, here is a new electronic cash system. It's completely decentralized, zero fanfare, just a quiet, highly technical release into the wild.
What's fascinating here is what happens exactly 2 days later.
The Weidai email.
Exactly. On January 10th, Satoshi sends an email to the cryptographer Weidai. And this email is, well, it's a massive piece of the forensic puzzle that the author highlights.
Because of the B-money connection.
Right. So Weidai, back in 1998, he had proposed this concept called B-money. It was a theoretical cypherpunk manifesto for a digital currency.
Way ahead of its time.
It was. It proposed a community-maintained digital ledger, and it even used proof of work. The idea that you have to expend real-world computational energy to create the money.
Which sounds very familiar.
Exactly. Sound familiar? In this January 10 email, Satoshi explicitly admits to Dai that Bitcoin, and I quote here, achieves nearly all the goals of the B-money proposal.
He practically spells it out.
Right. So when we talk about this grand revolution, we really have to ask ourselves, is it truly a revolution? Or is it just a buggy, delayed implementation of a 10-year-old failed idea?
Oh, con.
Because B-money, for all its brilliant theory, never actually got off the ground.
Okay, I have to push back on that framing. Calling it a buggy implementation completely misses the magic of what happened on January 8th.
I don't know if magic is the word I'd use.
Well, the true masterstroke wasn't the underlying theory. Yes, Weidai's B-money was brilliant, but it failed because it assumed a perfectly synchronous, unjammable network.
Which doesn't exist.
Which simply does not exist in the real world. B-money basically assumed everyone in the room was listening at the exact same time. Satoshi solved the asynchronous double spend problem.
Through the blockchain structure.
Right. It's like figuring out how to play a perfect game of telephone where half the people in the circle are asleep, a few are actively lying to you, and everyone is speaking at different times.
That's a good analogy.
Thanks. But the point is, the final message still arrives perfectly intact. That is what the blockchain solved.
Sure, in theory.
But more importantly, the masterstroke was moving the idea from a dormant PDF into runnable code. He took a decade of cypherpunk theory out of the academic ether and turned it into an executable file.
An executable file that barely worked.
But anyone with a standard PC could interact with it. That transition from theory to reality, that is the revolution.
Okay, but runnable code is a very generous term for what version 0.1 actually was.
It ran. Eventually.
The book's timeline proves this beyond a shadow of a doubt. Let's look at the exact moment that runnable code met the real world.
Enter Hal Finney.
Right, Hal Finney, a legendary cryptographer and developer. He downloads version 0.1. He installs it on his Windows XP Service Pack 3 operating system.
Standard setup for the time.
And what happens? It crashes immediately.
Well.
Outright exception. A complete, total failure to launch.
But the forensic logs show it was just a missing symbol file.
It was still a crash.
Satoshi simply forgot to include some debugging data when he compiled it. He recompiled the software with the debug symbols included, sent Hal a new executable, and it was fixed. It was a quick fix.
It was much more than just a missing symbol file. Because once they finally got the executable running, they ran straight into a fatal networking glitch.
A socket error.
Yes. The forensic logs in Chapter 3 detail this incredibly obscure Windows socket error. Specifically, select failed:1738 WSA not sock.
Sounds terrifying.
It was. This wasn't a minor user interface glitch. This error completely froze the network thread.
Meaning what, exactly?
It created what developers call zombie nodes. The client looked like it was perfectly online to the user, right? The interface was up, but it had completely stopped responding to all network messages behind the scenes.
Just totally frozen.
Stuck in limbo because a thread was blocking on a non-blocking socket. And then there were the compiler issues.
Oh, right, the MSVC6 thing.
Satoshi was testing his code on Microsoft Visual C plus 6.0 and GCC 3.4.5. He admitted to Hal that the MSVC6 optimizer was actually causing issues with the SHA-256 inner loop.
Wait, pause for a second. I need to play catch-up here.
Sure.
I'm not a software engineer from 2009. I get that a socket error sounds bad, but what does that actually mean for a network?
Okay.
And why does an optimizer issue in a compiler matter for a global currency? Break that down for me, because we really need to understand exactly what these technical failures mean for the money itself.
Gladly. So let's start with a socket error. In computer networking, a socket is basically a virtual plug.
Okay.
It's how your computer connects to the internet to listen for incoming messages. Imagine a receptionist at a busy hotel who answers a phone line where no one is speaking.
Just dead air.
Right. And instead of hanging up to help the giant line of people out the door, the receptionist just stands there frozen, listening to that dead air forever.
That's a great visual.
That's what the Bitcoin software was doing. It stopped talking to the network because it was trapped, waiting for a dead signal. That's the zombie node.
Wow. Okay. And the compiler issue?
Now, regarding the compiler's optimizer, a compiler translates human-written code into machine code.
Right.
An optimizer is a feature that takes mathematical shortcuts to make that code run faster. But here, the Microsoft compiler's shortcuts were actively breaking the underlying cryptography.
Oh, that's bad.
It was creating mathematical rounding errors in the SHA-256 hashes,
Which is the core security.
the very cryptographic locks used to secure the currency. We are talking about building a global economic infrastructure on untested, crashing software riddled with obscure networking errors.
You're being so harsh on it, though.
The MSVC optimizer issues alone are laughable for a system designed to handle absolute financial consensus.
You're judging a newborn by the standards of an Olympic athlete.
I'm judging a financial system by financial standards.
But you have to remember the context here. This wasn't a corporate product launch backed by billions in venture capital. They didn't have a massive quality assurance team.
Sure.
This was a two-person workshop happening over email in real time. I look at those crash logs, and I don't see amateurism. I see the Wright brothers' first flight at Kitty Hawk.
The Wright brothers didn't try to reinvent global finance on their first try.
But was their plane a fragile, sputtering prototype that could barely stay in the air for 12 seconds? Absolutely. Did it matter? No, because it proved that powered flight was possible.
It's a bit of a romantic view.
These bugs weren't catastrophic failures, they were evolutionary hurdles. Satoshi and Hal Finney were refining an invention for the entire world, identifying the atmospheric drag and adjusting the wings as they flew.
But look at the sheer panic required to keep that plane in the air. Look at the SVN logs outlined in the book.
The version control stuff.
Yeah, SVN, or Subversion, was the version control software used back then to track code updates. It gives us a minute-by-minute timeline of changes.
A real forensic trail.
Exactly. Satoshi pushes out version 0.1. He immediately has to push version 0.1.1 just to fix the startup crash.
Right.
Then version 0.1.2 to fix the peer discovery and connectivity issues so nodes can actually see each other. Then version 0.1.3 to fix the socket errors and zombie nodes we just talked about.
He was moving fast.
This is all happening within mere days. It's not evolutionary refinement. It's frantic triage to keep the patient from flatlining on the operating table.
But the patient lived.
Barely.
Barely, but it did. Those frantic point releases stabilized the peer discovery just long enough for the network to actually form.
Oh.
Which brings us to arguably the most precarious, breath-holding moment in Bitcoin's entire history.
You mean the January 10th tweet?
Exactly. Hal Finney goes on Twitter and posts two understated words. Running Bitcoin.
All lowercase.
All lowercase, no exclamation point. Just a quiet flag planted in the digital soil.
It's historically significant, yes. It's the first public proof that someone other than Satoshi was operating a node.
Right.
But the book reveals a survival constraint behind that tweet that completely undercuts all the romanticism of the moment.
Here's where it gets really interesting.
Very interesting.
And honestly terrifying if you think about the stakes. The source text pulls from Satoshi's emails to reveal a massive technical reality. Satoshi was operating behind a strict personal firewall.
A local network issue.
Right. Because of his local network setup, he could not receive incoming connections on port 8333.
Which is a massive problem. And to understand why that is a near-fatal flaw, you, the listener, have to understand how a peer-to-peer network actually starts.
The bootstrapping process.
Right. When a new computer joins a decentralized network, it doesn't intuitively know who else is out there. It needs a phone book.
It needs to ask someone for directions.
It needs what we call a seed node, an always online computer whose IP address is hard-coded into the software, so newcomers have a guaranteed first point of contact to download the ledger.
Exactly. And because Satoshi's firewall blocked port 8333, his computer couldn't act as that phone book.
He was completely unreachable to new connections.
So when Hal Finney connected and managed to finally get his Windows machine running without crashing, Hal became the de facto phone book.
By default.
For the first critical days of this supposedly decentralized, indestructible global revolution, Hal Finney's IP address was the only reachable node on the planet.
It was the ultimate single point of failure for a system entirely designed to have no single points of failure.
It really was.
If Al turned off his computer, the organism died. The network would have fractured, newcomers would have seen zero connections because they couldn't reach Satoshi, and the whole grand experiment would have just faded into obscurity as another failed cryptography project.
If Hal's computer goes to sleep, the blockchain stops. It's staggering to think about.
And this leads us right back to the ultimate irony of this entire deep dive.
The fan.
Do you know why Hal Finney eventually shut his node down? He turned it off because his desktop computer fan was too noisy.
It's almost funny in retrospect.
It was literally heating up his spare room and annoying him. Think about the absurdity of that.
I know.
We are debating a financial revolution, a supposedly unkillable sovereign protocol, and its survival was literally at the mercy of an annoyed guy in California deciding to turn off a loud CPU fan. That is the very definition of fragility.
Okay, but we have to ask why they were going through all this trouble.
Fair question.
Why fight the compiler bugs, the socket errors, the zombie nodes, the noisy fans? Why dedicate this intense intellectual labor to a sputtering prototype? I want you, the listener, to think about what safety means to your own savings and your own purchasing power.
It's an important concept.
When you put money away, what makes you feel secure that it will actually hold its value 10 years from now?
Well, for the vast majority of modern history, safety means institutional stability.
Right.
And this is where the macroeconomic context of the book is vital to understand the sheer scale of what they were trying to replace. We're talking about early 2009.
The peak of the crisis.
Exactly. During the 2008 financial crisis, the traditional financial systems were in absolute freefall. To prevent a total global collapse, central banks worldwide injected over $25 trillion in bailouts and quantitative easing.
$25 trillion.
That is the scale of infrastructure required to provide actual functional safety to the global economy. It requires massive, coordinated institutional power.
But at what cost?
A noisy desktop fan in Hal Finney's spare room simply cannot provide institutional stability.
But that is exactly the purchasing power trap that Satoshi was fighting against. The book's ideological chapters lay this out perfectly.
I know they do.
You call it providing institutional stability. The cypherpunks called it a massive orchestrated theft. Now, To be clear to you, the listener, we are not endorsing this specific economic viewpoint.
Right, just analyzing the source.
We have to understand the ideology presented in the source text. The book argues that while the institutional guardians were busy printing $25 trillion of stability, they were actively stealing the purchasing power of every future homeowner.
So inflation.
Yes. They were debasing the currency and inflating asset prices to save banks that had acted recklessly. Satoshi didn't embed the Times headline, Chancellor on brink of second bailout for banks, into the Genesis block as a joke.
No, it was a statement.
It was a manifesto. He was building an alternative because the so-called safe infrastructure was, in his view, actually a trap designed to dilute the wealth of the working class.
It's a compelling narrative, I'll give you that. But let's look at the reality of actually implementing it. You don't replace the global central banking system with an ideological manifesto.
You need a working system.
Exactly. You have to prove it works under stress. You have to prove it can survive real-world chaos without a central authority stepping in to fix it.
And he did. Look at the rehearsal detailed in the text. In November 2008, months before the software was even public, Satoshi sent a message to the cryptography mailing list describing an intense series of automated stress tests.
Yes, the packet-dropping simulations. I remember those logs.
Exactly. The book details how he wasn't just running the software in a clean room, he was programming computers across a private network to randomly send massive volumes of payments to each other.
Simulating heavy load.
And while doing that, intentionally dropping data packets to simulate severe network failures, he was artificially forcing the blockchain to split into competing versions, creating massive chain forks.
Just to see if it would break.
Just to see if the mathematical gravity of the protocol could force the network to self-correct and reach a single consensus again.
It's quite rigorous.
He wasn't just building a tech demo. He was rehearsing for an economy without masters. He was testing the system's ability to survive without a central bank stepping in to bail it out.
It's an elegant rehearsal, mathematically speaking. But before we wrap up, I want to leave you, the listener, with a paradox to mull over on your own.
Ooh, I like a good paradox.
It's what the author calls leadership by subtraction. Think about how a system achieves true permanence. If the creator had stayed, if they'd remained the visible leader, fixing every compiler bug, answering every forum post, managing every crisis, would the network have ever become more than a hobby?
Probably not.
It would have always had a CEO, a single point of failure that regulators could target or users could blindly trust. Consider how in some architectures, a system can only become an unkillable protocol by completely losing its architect.
In that first week, Bitcoin wasn't just code, it was faith. Faith that two people on the internet could create more trust than a 1,000-year-old bank.
Faith is for cathedrals. Financial systems require infrastructure. If your organism dies when a guy in California gets annoyed by his computer fan, it's not a revolution, it's a hobby.
But the fan stayed on long enough. In our next deep dive, we look at the first real transfer of value between human beings. Pen BTC that proved the ghost could move money through walls.